We were wrong about the planet Uranus. New study solves a long-standing mystery. New observations revealed that we were wrong about the length of a day on Uranus. According to the most precise measurements yet of the striking planet's rotation rate, a full day on Uranus lasts 17 hours, 14 minutes, and 52 seconds. That's 28 whole seconds longer than we thought, based on data collected by Voyager 2 on its Uranus flyby back in 1986. It might not seem like a big deal, but it actually is huge. Our measurement not only provides an essential reference for the planetary science community, but also resolves a long-standing issue. Previous coordinate systems based on outdated rotation periods quickly became inaccurate, making it impossible to track Uranus's magnetic poles over time, explains astrophysicist Laurent Lamy of the Paris Observatory. Uranus and Neptune are the two outermost worlds of our solar system, at significantly greater distances from the Sun than the rest of the planets. Uranus is twice the orbital distance of Saturn. Neptune is more than 3 times Saturn's orbital distance. And because they're so far, Uranus and Neptune appear small and dim, which makes them difficult to study. In addition, that distance makes them a longer trek than for spacecraft, so only the Voyager mission has been close decades ago. This means the information we have about the outer solar system ice giants is limited and may potentially be biased by the particular conditions affecting planets at the time of the flyby. Getting new information, on the other hand, is a bit of a challenge. The inaccuracy in our assumption about the length of Uranian days has resulted in some confusion. One of the biggest problems was that without an accurate length of day, the orientation of Uranus's magnetic poles was lost just a few years after the Voyager 2 flyby. To measure the length of a Uranus day, Lamy and his colleagues made a careful study of data collected by the Hubble Space Telescope between 2011 and 2022. In that time span, the telescope repeatedly observed the planet's ultraviolet auroras, which we see here, which are generated a lot like the auroras here on our Earth. As you can see here, they're on the horizontal axis. Now, particles born on the solar wind smack into the planetary magnetosphere and are whisked away and accelerated along the lines of the magnetic field to polar latitudes, where they're dumped into the upper atmosphere. Interactions between particles in the atmosphere and the incoming solar particles make a glow in the sky. One of the funny things about Uranus is that its rotational axis is almost parallel to the ecliptic, the orbital plane on which the planets all more or less move around the Sun, compared to the almost perpendicular orientation of the rest of the planets. So why is that? This orientation has made its magnetic poles a little harder to find. By tracking the ultraviolet auroras, Lamy and his colleagues were able to locate and trace the poles and use that information to precisely measure the length of the Uranian day. This measurement is precise, the most precise yet for the giant planet, and the researchers say even more precise than measurements of Jupiter's rotation rate. The technique used to measure the rate can thus be applied to the rest of the giant worlds in the solar system to obtain precise measurements of their inner rotation rates. With this new longitude system, we can now compare auroral observations spanning nearly 40 years and even plan for the upcoming Uranus mission, Lamy says. The research was published in Nature Astronomy magazine. This is by Michelle Starr on Science Alert. Please leave your comments and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.